A sample of argon gas at a pressure of 720 mmHg and a temperature of 45 degrees Celsius occupies a volume of 6.10 liters. If the gas is cooled at a constant pressure to a temperature of 30 degrees Celsius, the volume of the gas sample will be blank. Okay, so to solve this problem, we will be using Charles' law. So if you can recall the formula for Charles' law, that's V1 over T1 equal to V2 over T2. So of course, V1 is your initial volume, V2 is the final volume, T1 is the initial temperature in Kelvin, and T2 is the final temperature in Kelvin. Now let's substitute the numbers into the equation. So in the problem, our initial volume is 6.10 liters. So that's 6.10 liters divided by our T1 or initial temperature according to the problem is 45 degrees Celsius. But remember, when you're using gas laws, the temperature must be in Kelvin or the absolute temperature. So you need to convert degrees Celsius to Kelvin by adding 273.15. So 45 plus 273.15. So our initial temperature is 318.15 Kelvin. Okay. And on the right side, we have V2. So that's unknown. We don't know V2 because that's what's being asked in the problem. So just write V2 divided by our final temperature is 30 degrees Celsius. But again, you need to convert that to Kelvin. So 30 plus 273.15. And that will give you 303.15 Kelvin. So how do you solve now for V2? So this is simple. All you need to do is multiply both sides of the equation by 303.15 Kelvin. So you multiply the right side. You also multiply the left side. So on the right side, 303.15 would cancel out. So the remaining variable on the right side is V2. And on the left side, as you can see, the Kelvin would cancel out. So you now have these numbers on the left side, which you can solve using your calculator. So 303.15, you multiply that to 6.10 divided by 318.15. And you will get an answer of approximately equal to 5.81. And since we are talking about volume, the unit must be in liters, since V1 is also in liters. So 5.81 is the answer to the question.